So we're using AC supply to run the microcontroller and the two ICs. This IC is the DTMF IC. So from the cell phone, you can see that there are two wires. One goes to ground while other is the input. Here, this is the non-polarized capacitor. What it does is it filterizes all the noise and then just sends the DTMF signal. It goes through the capacitor, and there are like 5 bits as output. Well, this bit, the last bit, is the authenticity bit, while the others are the information bit. So I've sent the output from this chip to GPIO-B in my microcontroller. So what my program does is it checks the pin, and then according to it, it gives the output to GPIO-A, and GPIO-A is connected to my motors, and this is my motor, and there are like 4 outputs for the wheel, which is down. So now we're going to see it working. So it's the both motors are rotating at the same speed over here. I have kept a delay of 3 seconds. Now I'm gonna send another DTMF. You can notice that the speed of one motor is different from the speed of the other one. Well, same thing happens when I send DTMF of 6. You can see the rotation speed is sort of different from one motor to other motor. And now for reverse, I send 8. Reversed. So this is to check that the data is working properly on oscillator. So you can see oscilloscope. So I send a DTMF, and you can see that this is the authenticity bit which has gone high, and this is the data bit of 2, which is high most time. Now I send another DTMF for. You're going to see that the screen has gone low and there is an authenticity bit.
The picture was taken from the oscilloscope. The 2 lines represent a data bit which gets high when a DTMF of 2 is sent, and the other is the authenticity bit. In this picture, in a brief of time, I send 2 and 4 in DTMF. First, when I send 2, the authenticity bit gets high for a short time, and the data bit pin is set high until I send another DTMF.